if you were to take all of our tests and run them one after another, it would take somewhere between 4 and 7 hours to serially execute everything. Successful, like totally green builds were actually like really rare. Why is this happening? Everyone always goes into these bug bashes with the attitude of we're going to fix it once and for all, which is never true. I came out of that process just like absolutely frustrated and confounded with the state of our build, and I just decided to fix it. So this was like our first really surprising result.
Welcome and good day, everyone. I'm your host for this Gradle webinar, Oliver White, and joining us today for Lessons Learned Modernizing Apache Kafka CI Builds with Develocity and GitHub Actions is my new friend, David Arthur. David is an Apache Kafka project committer and senior staff software engineer at Confluent. Now, I only met David a few months ago, but I already know that he is not a fan of excruciatingly long build times, never-ending flaky tests, and poor developer productivity. And that's what today's story is all about. David will walk us through the lessons learned early in 2025, addressing painful and unreliable 8-hour build cycles, difficulty troubleshooting, and test flakiness. Migrating from Jenkins to GitHub Actions is the first piece of the story, and David will then explain how deep observability from Develocity made the migration significantly easier and possible to show evidence of a clear ROI. Later, he'll talk about the importance of build caching for speeding up CI infrastructure and how deploying Develocity flaky test detection across their 34,000-strong test suite saved their sanity and removed a lot of red in their test ledger. This is a really great story, so let's get to it.
Yeah, thanks for having me. It's great to be here. Thanks for the intro. I got a few more little tidbits to add about myself. And now that the Zoom has zoomed out, you can see my cool Apache t-shirt that I
Of
got
course.
with the sporting the new logo, no less.
Ah, there's probably
Um,
going to be a question about that, which we can
sure.
avoid tastefully if you care to.
Yeah, I'll field that. Um, great. So yeah, just a few more things about myself before I kind of jump into the bulk of the talk. Um, personally myself, I've been a user of Kafka since before it was Apache Kafka. So back in the, many, many years ago, it was a project, an internal project at LinkedIn that they open sourced and eventually decided to contribute or donate to the Apache Software Foundation, became an incubator project. And this is around the time that I kind of got involved as a contributor of Kafka. So in 2014, I was invited to become a committer and made some kind of very early contributions to the project. My most notable contribution from that time period was actually writing the original Gradle build. So it was in the very, very early days, Kafka was 100% Scala and used SBT, which was really not loved by anyone. And redoing the whole thing as Gradle was like a big early improvement. And we still use that build today. It's evolved quite a lot over the years, but it's still mostly the same as it was originally written. I took kind of a break from the project because my day job sort of pulled me away from working on Kafka. So there were some years there in the middle where I didn't really do too much. I still would check in at least once a year to, fix something in the build or, fix a bug here or there just to stay active. But when I joined Confluent 7 years ago, I started working on Kafka pretty regularly, becoming one of the kind of core committers. And in 2023, I was invited to join the PMC, which is the Project Management Committee. That's pretty much it. That's the history. So, despite not really like being a build enthusiast, I do end up working on it quite often. Though I do work on a lot of other things in Kafka. So most recently, I was pretty heavily involved in the Craft project, which was Kafka replacing Zookeeper with its own internal managed metadata. And I also was kind of the primary person driving the migration away from Zookeeper to Craft. So hit me up if you've got any questions about that, like on the ASF Slack or Jira or GitHub or whatever. So jumping in, first thing I want to talk about is kind of what we did to kind of drag ourselves out of the Stone Age and modernize our build. And we'll see how Develocity was a critical piece of this as we go through this. So Kafka is a pretty big project. It's a very active open source project. We have around 60 so committers and hundreds and hundreds of community contributors. In a typical week, we'll see between 30 and 40 commits, and that number can go up to maybe around 100 commits on a really busy time, like when we're preparing a release. Another side effect of being kind of a older project, being around for more than a decade, we have a pretty robust test suite. As Oliver mentioned in the beginning, it's 34,000 tests last time I counted. It's probably more today because we've added some pretty significant features recently. So these are a combination of unit and integration tests, all JUnit. So it's all Java tests that I'm talking about. We do have a separate set of like system API tests, but we won't get into those here. So, just in case anyone is not aware, an integration test is, well, at least to us, the way we define it is a test where we actually start up a server, listen on a port, open a file, do something kind of real, not just totally, simulated or the kind of low-level unit tests. If you were to take all of our tests and run them one after another on a pretty average machine, it would take somewhere between 4 and 7 hours to serially execute everything. That's kind of that's an issue, right? And also, we don't just build for one target environment. We build multiple versions of Scala and Java. This means we need parallelism, right? We need lots of things to be happening at the same time. Otherwise, we're just like totally stuck, and our throughput becomes very limited. There's only a certain number of hours in a week, and if our build, and this is kind of what we were saying with Jenkins, our builds were taking around 4 hours, even with parallelism, meant that our throughput was basically around 40 builds per week. And I'm just talking about our mainline branch where we need to run one build after another. How do we handle 100 commits per week, right? It sort of becomes a problem. We get, a big backlog in our build. Prior to August of 2024, we were exclusively using the Jenkins that was managed by ASF Infra. And this is set up as a classic kind of controller worker architecture. So you submit your job, it goes in a queue. The Jenkins controller looks at the eligible pool of workers and picks one to run the build on. And as we started to scale up our build and increase concurrency in Gradle, and by that I mean turning up the number of workers in the Gradle process, or rather the number of processes managed by the Gradle daemon, and then also the number of threads, we noticed that our builds did get faster in some cases, but in most cases, we were getting really inconsistent build times. We also started seeing a ton of flakiness start to creep into the system at this point. If you've studied flaky tests or read about them before, you'll know that increasing concurrency is a pretty well-known source of flakiness. Hey, it works on my machine where I'm running just a single test by itself. But when I'm running it on a heavily loaded, piece of infrastructure running a bunch of other builds, we start to get timing issues, garbage collection, weird delays, stuff like this. So that wasn't too surprising. But what was really bad and really difficult was diagnosing these failures on Jenkins was really difficult. We also saw flaky behavior as a result of things getting stuck. So these were like bugs in our test platform, like race conditions during shutdown or like failure to retry in certain cases. All of this kind of came together and led to a situation where successful, like totally green builds were actually like really rare. That was, not not a good situation. The other aspect of this is that we had lots of builds kind of getting stuck, as I mentioned. So, we want to set a timeout to like prevent those from just running forever. Well, how do you pick the timeout? Because if a healthy build takes up to 4 hours, you kind of have to give it some headroom because we don't want to cancel a build that's going to pass because those are so precious and rare. So what we ended up doing in the project was setting our timeout for 8 hours. And that was not infrequent to see, not an ideal thing. So another problem we saw with Jenkins was noisy neighbors. So this is basically, you start to see more flakiness or more slowness because another build is running on the infra that you're targeting. So all this kind of comes together and leads to a very, very poor developer experience. Typically, for a Kafka contributor, you would update your pull request. This would trigger 3 Jenkins jobs, and you needed all 3 of them to be green in order to really say, hey, this is good, let's merge it. Well, when I looked at the numbers, this was like below 0.1% of the time you would actually see all 3 builds pass. The way we would actually do it in practice is we'd say, oh, well, I reran the build 5 times and I got a successful build from each of those once before, and people would just sort of take your word for it and we would merge the code. So, like, pretty bad overall situation. Before we jump into what we fixed, let's think about like what does a big project need from a build? For Kafka, what we needed primarily was stability, right? We needed builds not to just fail for some random reason because of the infrastructure. This wasn't super common, but it did happen occasionally. The next one is predictability. I really, really think that a build should be very predictable and consistent. So when you submit your change, you should roughly have an idea in your head of how long it's going to take before you get feedback, right? This helps us kind of subconsciously do time management, submit a build, go get a cup of coffee versus go get lunch, right? And having that predictability, I think, is really, really important. And the last thing we need for a big project like Kafka is scalability, right? So we've got a lot of contributors, we've got a lot of pull requests being built, a lot of commits landing on our mainline branch. We need a system that can keep up with our rate of change. So those are kind of the problems we had. And if we go back to 2024, as I was finishing up the kind of the work for Craft and Zookeeper migration, I had, as you might expect for a big feature like that, I had made a lot of pull requests, like several dozen over that, those few months I was working on that. And I came out of that process just like absolutely frustrated and confounded with the state of our build. And I just decided to fix it. The first thing I wanted to do, and this was something that I had in the back of my mind for a long time, was, all right, let's speed things up by caching. All right. So we'll flip caching on and everything will be faster and it'll be great. Okay, that didn't help. Well, we couldn't just simply flip it on. One of the problems is that a cache needs some sort of persistence between builds, right? Your build populating the cache needs to do that, and the cache needs to be stored somewhere that's then loaded for subsequent builds. And that was really difficult to do on Jenkins. In fact, it was not possible. We kind of explored it for a little bit, and we just decided it was not really tractable to do on Jenkins. So I'd also seen and read a little bit about this GitHub Actions thing. So maybe it can help us with some kind of persistence. And that's what we did. Did a little prototype, and mainly this was just to see if we could use the caching feature built into GitHub Actions to leverage the Gradle cache and, see how it works. So this, if you're not familiar with GitHub Actions, it's basically like somewhere between infrastructure as a service and a build system. It's like essentially like, go provision a worker, run these actions on it. There's a little bit of control flow built into it. There's like conditions. There's all kinds of triggers. So, it's not dissimilar from Jenkins. It's actually pretty similar, except it's kind of architecture is a bit different. We come up with a plan. We're going to build an MVP of the build with the cache and run it alongside Jenkins for 30 days. And then after this, we're going to discuss it with the community and the committers and decide if it was a go or no go. And so, if you're going to do an experiment, you need data. And, we needed a system to collect data. And as Oliver mentioned, also, as an Apache project, we had free access to this really cool tool called Develocity. So we want to be rigorous in this comparison. We want it to be as apples to apples as we can. There are APIs in GitHub Actions to like get data about your builds, but Jenkins doesn't really have much to offer there. And in fact, for the very early comparisons, I was actually manually just clicking on builds and jotting down the time it took. But Develocity made this very, very easy. So there are these things called build scans. So after your build runs, all this like telemetry data about your build is published to Develocity, where you can see not only the historical record of that individual build, but you can look at trends across time, which is really, really nice. Another nice thing about build scans are these tags. And so, we were able to set up a few simple tags that let us kind of see, okay, here are the Jenkins build scans and here are the GitHub build scans. We also added one for trunk, which is our mainline branch, and a local one for developers running on laptops. We let this run, and really after a few days, we discovered, the build scans are really awesome. And I think it's probably safe to say that you're watching a Gradle webinar. You're probably familiar with Develocity and build scans, but I'll just do a quick little plug here for them. They give you, I have screenshots later we'll look at too. They are really just so much better than trying to download logs or like look through, um, just a list of builds on a system like Jenkins or even GitHub Actions. GitHub Actions doesn't really give you very much. It's just like, here's your build at rand, here's the outcome, download logs, right? So Develocity or build scans specifically, give you like these performance trends, test trends, a bunch of metrics about individual builds, gives you information about the system that it was run on, which is actually how we discovered that these GitHub Actions runners only had 4 gigs of memory. We didn't realize that for until we started looking at the build scans. But yeah, they're pretty awesome, and they support Maven and Bazel, I think, as well. Um, but obviously, they work best for Gradle, which is the best build system. Right. So let's take a look at some early results. So after about a week or so, or maybe 10 days, we had enough data to really kind of see something. So this was our Jenkins builds. And you can see this kind of matches what I was describing earlier. In the best case, which would be kind of towards the bottom of the charts here, we're like in an hour and a half kind of range, which is like pretty good for this build. The average case is around 4 hours, which is what we've been seeing. That was not surprising. And then the worst case is like when we're seeing timeouts up at 8 hours. There's still a bunch of like these outliers in the like 5 to 6 hour range where the build does complete. It's just really, really slow. Those would be the noisy neighbor cases. So when like another build is running on that infrastructure. Yeah, here, 5th percentile, an hour and 20 minutes. That's actually pretty respectable. So here's GitHub Actions. This was really shocking, really, really surprising to see. So the fastest time, the 5th percentile time, is a bit slower. It's an hour and 37 minutes. But the worst time is barely any different. It's only an hour and 59 minutes. So this was like our first really surprising result, which was we've compressed the possible, runtime of the builds from anywhere from an hour and 20 minutes to 8 hours to now everything is running in this very narrow band of time. And so we're like, what is going on? Why is this happening? And as I mentioned, these GitHub Actions runners only have 4 gigs of memory and 4 little puny CPU cores, whereas these Jenkins machines have hundreds of gigs of memory and, whatever big, beefy, enterprise grade processor that the infra team stuck in there. So why is this? What was going on here? Why is this happening? And we realized pretty quickly that this is because Jenkins completely lacks resource isolation. Or rather, I should say, Jenkins is just relying on the operating system for resource isolation, which is not ideal. GitHub Actions kind of run in containers. So it's like I think it's run on Azure actually. But it's a Docker thing. It's like running in a container and it uses up all the resources of the container And so your resource isolation is at the container level, which is going to be a lot better than just like the OS, right? Because the OS is going to let any process, unless you do like, weird Linux things, the operating system is just going to kind of let processes do whatever they want and use whatever resources are available. We kind of realized that isolation in a build system is super, super, super important. It stabilizes your builds, and stability in a build leads to that consistent runtime and very repeatable results. We didn't change anything else about the build except for where it's run, and we had this dramatically improved outcome. So we kind of thought maybe we should just stop here. This is pretty good. But of course, by moving to GitHub Actions, we unlocked a whole world of possibilities of cool things to do. And I was really determined to get this caching thing working. So we're going to move on to caching. The basic strategy here is to populate a cache with builds from trunk and then use that cache on pull requests. And the hope is that if your pull request is pretty much up to date, you're only going to run tests for things that have changed in your pull request. It seems like pretty obvious, right? But it's actually not that easy to get working. We found several pitfalls when using the kind of built-in caching with the setup Gradle GitHub Actions, and which uses the GitHub Actions cache. One is that, and really this is only important if you're planning on using GitHub Actions, but the writer and the reader, the jobs have to have the same name. I'm really not sure why. I think it has to do with how they generate the cache key, but that was kind of a subtle thing that was not obvious. It's really easy to break the cache, and this is a Gradle thing. If you have any kind of timestamps, basically if you have any non-determinism in your build, right? If you have the same git SHA and you do a build and then you do the build again and any of your artifacts are different, caching isn't going to work. So you have to take some steps to make sure you're not putting like a file with a timestamp in it, for example, like in a build manifest or something. And you're not putting your git SHA into an artifact. What we did for Kafka is we found places where we were doing that and we kind of externalized it. So you could pass in an environment variable that would populate those things. And so for the CI builds, we can just put in some fake thing so that we get the kind of deterministic, repeatable builds. So anyways, the caching is also pretty hard to debug. Like when things aren't working, it's not really obvious. There's this like really nice flag you can set that I've mentioned here at the bottom, which gives you a whole bunch of output, makes it easier to kind of see what's going on. I will say that Develocity was actually quite useful to look at the build scans to try to figure out, okay, this task was cached, this one wasn't. And it does let you kind of glean a little bit of information about the task graph and also, maybe what inputs have changed for tasks, which can also break the caching. But, short answer, the summary of this slide is basically it's not as easy as you think. But we did get it working. And the results were noticeable, but a little underwhelming, I'll say. We did shave off around 15% of pull request build times. In the best cases, we save like 75 to 80%, and we can see that today in our builds. So if you change documentation, for example, like most of the build, it doesn't run. It uses the cache instead. And so, we saw our median build times reduced by a little bit, 2 hours and 3 minutes to 1 hour 58. So not that much. The average build time did decrease a decent amount. And of course the like extremes increased a lot. So the fifth percentile is much better. It's 12 minutes. And here's kind of the before and after. So we can see that this is taken from I forget when these screenshots are from, probably August of last year. In August of last year, our build was 7 hours 45 minutes serial execution time. So that's one task run after another, no parallelism. In that time scale, we shaved off 2 hours and 3 minutes of build time. So this doesn't translate to 2 hours of like wall time that you save. but it does, it's kind of distributed based on how you have your parallelism set up. However, the interesting thing is that if you look at the 7 hours to 2 hours, it suggests we're saving 25% of the time. But that's more than what we're seeing in these metrics. Okay. In those metrics, we were seeing like 15 to 17%. So that's like a discrepancy. That's like a 10% discrepancy. So how is it that we are avoiding this much of the build, but the overall times, aren't improving? Again, this is where Develocity gave us some great insights. Doing a build cache is not magic, right? You are still going to be limited by how your project sets up, how it organizes your tests and how your modules are organized. So Kafka, unfortunately, and this is improving, Kafka has very coarse-grained modules, right? And you can see that here in our build. We've got like maybe like 10 or so you can see. And what that means is each and that's kind of the unit of that's like the schedulable unit for Gradle, right? Is like what task is running. We can see here that we have this one task that's increasing the overall build time by a decent amount. And we would see this very, very consistently, which actually means this is kind of a bin packing problem, right? So if you've got a bunch of large tasks that you're trying to fit into 4 buckets, you're always going to overfill one of them, and then your overall time is going to be exceeded. So it would be nice if we could cut off the tail of this streams integration test, divide it into 4 parts, and then spread it evenly, because that would decrease our build time, right? That's where the lack of magic kind of comes in. That just doesn't happen. You have to do that yourself. This was kind of like another lesson we learned is that we need to have smaller, more fine-grained modules to allow for better scheduling and better balancing of tasks among the available workers. So that's what we're sort of doing now. It's happening here and there in Kafka. We are basically trying to break up our dependencies a bit, so we have less of a just linear kind of dependency kind of tree, if that makes sense. So, for example, if you got B depends on A, so the dependencies are flowing down. So if anything in A changes, you're going to have to rebuild A and B, right? So, but if you can decompose your modules a little bit, and let's say you have your A API module and your A runtime module, well, if you change the runtime characteristics of A, then B doesn't really care because the contract has stayed the same. And this is something we're sort of pursuing in a few places in Kafka, is kind of separating things out into their contracts and their runtime. And what this does is it really helps the build graph minimize things that have to run. So now B will only get rerun if you actually change the contract of A. So that's kind of nice. And you might be thinking that, hey, this isn't totally safe. And that's correct, because you can introduce bugs by changing the behavior of something that, like, you could change the behavior of A that would cause a test to fail in B. And that's true. And that's why we don't use any caching on our mainline branch. So we always run all the tests on trunk. And that's basically to catch issues like that. So yeah, this is our kind of like I said, our third lesson we learned is that, you know, smaller modules are better. They help reduce the dependency graph and helps improve the bin packing of tasks onto Gradle workers. It's also just like good design, frankly. So this was like the other kind of big takeaway here. So part 2, flaky tests. I mentioned a little bit about flaky tests earlier. This became the second thing we turned our attention to. Once we had a nice, stable, predictable build, I guess I skipped over something. We did decide to go and switch to GitHub Actions. So after the evaluation, there was a lot of very positive feedback in the community, and developers were just over the moon happy about being able to see green builds. But I was not quite satisfied, because after we made the switch and we started running for a while, we still had this chart in front of us. And so this is the number of builds on our mainline branch which were failing due to flaky tests. Like many projects, Kafka goes through these kinds of cycles of periodic bug bashing where the test suite just gets worse and worse and worse until it's unbearable. And people just say, that's enough. We've got to fix it. And, everyone always goes into these bug bashes with the attitude of we're going to fix it once and for all, right? Which is never true. So this is what we used to do. And you could kind of see things like there'd be some improvements, the build failures would decrease. And then, over time it would creep back up and creep back up and then eventually, become unbearable again. So after the switch, we could see here that over this 30-day period, 23% of our builds failed from flaky tests. Now this is down from like 90% or whatever with Jenkins, but it was not good, right? This was still a pretty bad experience. And the other problem is that if you want to use caching, you won't be able to populate your cache from a failed build. So we really, really want mainline builds to be green, right? That should be a given, but it had been so long since that had ever really been the case in Kafka. We were used to seeing broken builds. Unfortunately, we still do have them, but as you can see now, this is the last 90 days. Only 3 out of the last 600 builds have failed from flaky tests. So we have made improvements. Yeah, the nice thing is with this is we also now have the time to investigate each of these. So, thinking about it from an engineering like DevOps kind of perspective, a failed mainline build should be like an incident, right? It's like some problem made it past our gates, our checks. Our CI has not done its job and some bad thing has landed on our main branch. Like that's an incident, right? You have to respond to it quickly. That was absolutely impossible to do before because there were just too many of them. Now, okay, we have 3 in the last 90 days. That's not perfect, obviously, but that's something that's actionable. That means that someone can say, okay, well, let's go see what happened here. Is it just a test that needs to be disabled? So some infra problem, whatever. Although I'm sure everyone here is familiar with the scourge of flaky tests. Here's like my definition. It is a test which, for identical code, sometimes passes and sometimes fails. Okay, I probably didn't come up with that definition. I'm sure someone else has said that too. But there are a variety of reasons for what causes a flaky test. Non-determinism in your code, so random, or clocks are a big source, which is the second point here. Wall time versus, like if your test is like going to go to sleep to wait for something else to happen, that's going to be flaky, like guaranteed. Concurrency in your code can be a source of flakiness. Concurrency in your build can be a source of flakiness. That kind of gets into the noisy neighbor thing, which is the next point, which is the environment. So, what's going on with the disks or the network? Is some like benchmark running that's just absolutely like in a tight loop hammering the CPU. And then there's other, more, I guess, cheeky things. But I think this probably cosmic rays have at some point caused build failure in the history of computing, I'm sure. A very common first step to alleviate flaky test failures is retries. And I am a firm believer in retries. Okay, some people say, oh, retries are just a band-aid. But I actually think that they're essential because even if you write perfect code and perfect tests, you're never going to be running on perfect infrastructure. And there's always going to be those like weird edge cases that cause some kind of sporadic failure, right? So a light sprinkling of retries, I think, is very, very useful. So Develocity has a plugin for Gradle. So in addition to being the web app that has your build scans and lets you do all this cool analysis, it's also a feature built into Gradle that does retries. This is basically like a policy. So you can define these for different, in all kinds of different ways, but we have a pretty simple one for Kafka. We have max retries and max failures. So what this says is that each test can retry once. We can tolerate a total of 10 failures, which are retried, before we stop retrying and the build fails. Okay, so what this means is that across my entire test suite, I'm not saying which test, any test can fail and then be retried once, and I'll still count it as okay, as long as there are less than 10 occurrences of that across the whole build. This max failures is super important because if you had some like, configuration error or something that was causing things to fail, you might end up running every test twice, which would lead to a really slow build. So setting a limit there is super important. The other reason why I think retries are very important, and this is a little philosophical, I guess, is that I think it is bad for developers to go click a retry button because humans get into we fall into patterns very easily, and like we get like trapped by our routines almost. And if developers become accustomed to going in and just saying retry, 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 they're going to start ignoring failures completely and just go to that button that sometimes gives them what they want, right? You could probably do a psychology experiment on this or something. So I think it's very important that the system does the retries and not the developers. Of course, there are going to be cases where you need to retry a failed build, but like that should be the exception, right? The other really nice and very, very useful thing that we get in Develocity are these test reports, specifically the Flaky test reports. Once you have a retry in place, you now can start generating data. And this is kind of like almost like a recipe for how to approach Flaky tests. So first you turn on retries, make it pretty like, pretty lax, I would say. Like let it tolerate a lot of problems. You're really just trying to get the green build at first. And then you start generating data. And from this data, you can identify your problem areas. So you can just go into this report in Develocity and sort by flakiness, and just boom, there's your culprit, right? 24% of the time this test is flaky. That's terrible. We kind of unofficially say 10% is our like threshold. If a test has less than 10% flakiness, it's a problem and we want to fix it. But if it's more than 10%, we want to fix it now. That's kind of where we're at in Kafka. The next thing you need to do is take action based on this data. What we do, and what I think is a very good strategy, is to have a very aggressive disable and fix policy. So if you find a flaky test, you don't just let it sit there rotting in the code while you work on a fix. You turn it off just immediately. You disable it. You can use, depending on your test framework, there's lots of ways to do this. We added a custom annotation called Flaky just to make it super obvious. And also it requires you to put in like a string. So we also want Jira tickets for tracking this. So once it's found, you want to basically disable it, document it, which is what the tag is about, and commit it like straight away, like quickly within a day, hopefully, of finding it. And so what this does is it takes away the impact of that test on the main test suite. So the build can start being happy, and it kind of gives you time to work on it and do a proper fix. So you're not kind of racing against the clock, right? You're not like, oh, if I don't get this fixed today, it's going to keep breaking builds. No, just fix the build first and then work on your test fix. What this also does is it takes that stress off, which prevents people from doing like a quick fix that they think will help. That's something I've seen a lot of, where there's a flaky test and then someone will commit a fix, but then the flakiness is still there. So they'll commit another fix and the flakiness is still there. And it just takes forever to really get to the bottom of it. So disabling it lets you really take your time and work on like a proper fix. I said disable, and that was a lie. I'm sorry. What I really meant is you want to take them out of the main test suite and move them into their own test suite. And this is what we do. And we call this the quarantine suite. So this is a separate job that's run, like not part of the main test suite. It's a separate total job. And what this does is it allows us to run these tests with a more permissive retry policy. It also, isn't a big red flag when this test fails, right? If the flaky test suite fails, well, that's not surprising. It's the flaky tests, right? But we've pulled the impact out of the main test suite and into this much smaller one. It helps keep the builds green, basically. So the reason we do this is because after you've made a fix for a flaky test, how do you know you fixed it, right? Well, it works on my machine isn't going to cut it. So the test needs to be enabled somewhere. It needs to be running regularly, generating data, so we can go look in Develocity and see that indeed it has been fixed. That's exactly what we do. So once a test has been quarantined, it still gets run, still generating data, and then we use Develocity as our evidence that, hey, turns out I've actually fixed this. There's been no failures in the last 10 days. And that is when you go and you remove that flaky tag and re-enable the test in the main test suite. There is another case, which is when tests are just wrong or broken, and those do just get disabled. So we do still use the JUnit disabled annotation in some cases, which just turns them off completely. But that's not so common. In my opinion, you should just delete tests like that. That's how we kind of handle existing flaky tests. But it turns out, even if you fix all your flaky tests today, that's not going to fix the problem forever, because making changes to your code and adding new tests is actually the primary way that flaky tests are added to a test suite. So we came up with this idea. We're gonna use the quarantine as kind of also like a staging area for new tests. So what we do is when a test is added to the test suite, it's automatically quarantined for a week. So you don't have to tag it or anything like that. It's just detected that it's new, and it's run as part of the new test suite. And it's run with a I can't remember. I think it's run with the same retry policy as the quarantine, just so we get more data from it. I'd have to check. But anyways, we run it separately. And what that does is it lets us see, oh, is the new test suite failing? And if it is, we go see, we added a flaky test. Well, let's go ahead and quarantine it and mark it as flaky before it gets automatically promoted to the main test suite. So this kind of workflow has been very effective at letting us keep the flakiness down with kind of minimal effort. So again, new test is added. It's automatically on track to get added to the main suite after 7 days. In the meantime, it's run as part of the new test suite. And during that time, we monitor for it to see if there's failures or flakiness. And if there is, we redirect that test for the flaky test suite. So this has also been a pretty useful workflow that we came up with. The way this works is kind of interesting and tricky, and I think it'd be a great feature for Gradle, for the Gradle people in the audience. We actually we have just some code we've added to our build, which spits out a line into a file. As we discover tests, we basically spit out a line into a file. Those are organized by module and sorted and put into a big YAML file, which is checked into a special branch on our main line. And what that does is it lets us check out that, and that's done after the test suite is, or as part of the test suite running on mainline. So then when we're doing a new build, we actually check out that file from that special branch. Essentially, we check it out at a previous point in time. We feed that into the build, and then the build can say, as it's scanning through the tests and discovering tests, hey, I don't see this test in my catalog, so it must be new. So it automatically gets put into the new category or something. And it's all just like automatic, uses Git for persistence, but it would be a good Develocity feature, I think. So that is how that works. So this takes us to kind of the end of the talk and our final lesson, which is not just about flaky tests, but about builds in general. And is that it takes the whole community to really have a good build and a good system. I very strongly believe in no broken windows, right? There's like this like philosophical fallacy of like, if the building has broken windows, it's not going to get the funding it's needed to replace the windows because people just start ignoring it and they get used to the broken windows. But you get the idea. Like if it's in a bad condition, people just get used to it and they start ignoring the problems. That's a bad situation to be in. You want your mainline build to be really rock solid and always green, right? Or blue, I guess, depending on your CI system. It's also important, when you come up with these ideas on how to manage things like flaky tests or failed builds, is to write it down. Like have an explicit policy written down. This should go in your website, like developer information, a wiki, somewhere in the code, like somewhere, right? It needs to be communicated to people. So there's not just like one or a few people who care about the build who have this information. Like everyone can just, oh, that's how we handle flaky tests. You want to minimize developer toil, right? This is like the mantra of DevOps people everywhere, or dev prod people, I should say, developer productivity. We don't want our developers having to like do a bunch of like repetitive stuff, right? We certainly don't want them clicking on rerun a whole bunch. You just want things to kind of work. A really important thing, I think, that I've been really trying to drive as part of this, because I had to like, as part of this whole thing, I had to go, you know, I would do a lot of work, get things working, and we'd have green builds, and then somebody would break it. I'd be like, oh my God, I'm so frustrated. But you really have to adopt this kind of like inclusive, blameless culture of like not like shaming people, like, hey, you broke this, go fix it. But rather you come to them from a position of, hey, this thing is broken. Can you help me fix it? And usually when you do that, most people will be like, oh crap, I'm so sorry, and they'll go fix it. But the way you talk about it and the way you communicate with people is really, it really does matter. And so I think that's worth kind of calling out here. That also, I think, helps foster the kind of ownership thing a bit. If you're the one always just trying to fix things, people are just maybe going to lean on you a bit, right? But if you engage with other people to sort of help with the fix or drive or do the fix, it kind of shifts that sense of ownership more back onto the developers, I think. The most miraculous thing about this whole everything I just described is I actually haven't touched it in about a year. So I've been working on other stuff. I haven't been working on Apache Kafka very much recently, and it's all just working, right? The community has like really stepped up, keeping the tests like healthy and the builds passing, and it's just been so cool to see like people, like it's like when you give them the right tools, they'll use them, basically, I think is the lesson there. So the next steps for Apache Kafka, whenever I get some time or whenever somebody else feels like helping with the build, we do want to check out and use Develocity's remote build cache. There's some like API things like an API key issue there we need to sort out with infra. We really desperately want to use the merge queue for GitHub, but we can't. At least we haven't figured it out yet. There were like a bunch of like legal hurdles we had to get through with infra before we got their blessing. But now it's like, it's basically just like a limitation of GitHub. Like the way they auto format the commit messages is kind of problematic, but we still really want to use it because it helps a lot with preventing weird conflicting like code from landing on your main line that causes test failures or compile errors. We want to continue refactoring modules to be more modular and more cache friendly. And one of these days we'll figure out how to get some funding to like some bigger infrastructure. There is some discussion, I believe, about Apache Infra maybe doing self-hosted runners. Like they buy some infra somewhere and set it up, and then we can use that. I'm not really sure what's going on there, but essentially we've made this much progress with the little the cheap little 4 gig 4 core GitHub Actions runners. And if we can just get the big ones, we'll probably speed up our builds by like 20 or 30% would be my guess. And if anybody wants to help with the Apache Kafka build, please contact me. Because there's only a couple people in the project who really know much about it. And I don't have time these days to really work on it. Thanks everyone for tuning in and listening. I want to say a special thanks to the Apache Software Foundation and the infra team specifically, who I worked with a ton to get all these things working because it was not straightforward. I got a lot of help from the friendly folks at Gradle Incorporated, and of course to the whole Apache Kafka community. That was, obviously they were instrumental in this whole thing. You can find me on GitHub, LinkedIn. I did start this Substack when I originally wrote this talk, which kind of goes into some more details about like more about the how we did it. But I haven't posted anything in a while. Fair, just be warned. But there it is. And that's it.
All right. I want to thank you for this excellent story. Our audience was really quite engaged and interested in your lessons learned, and I wish everybody a productive day.